Okay, let's say we have two curves and we want to find the area between them. So let's say we want to find the exact area that's enclosed in the region bounded by them. To do this, we would have to use indefinite integrals. So first, we would have to take the area of the top function and subtract it by the area of the bottom function, and that's because the top function will give this part of the area and it's bounded by the intersections of the curve, and the bottom function will give the area under this part. So once you take this and subtract it by this, you'll get the area that's enclosed. Same way we can do it if we want to find when we have a function with x equals f of y. It's the same process, except instead of taking the top function and subtracting it by the bottom function, we would take the right function and subtract it by the left, because this indefinite integral will give us the area from the curve to the y-axis, and here it'll give us from the curve to the x-axis. So instead of top to the bottom, we'll take right to the left. So the right curve will give us this area, the left curve will give us this area. So if we take this and subtract it by this, we will get the area between this curve. Question 1, we have, find the area of the region bounded by the functions y equals e to the x and y equals x between x equals 0 to x equals 1. So here is a graph of just a sketch of what e to the x and y equals x looks like. And we're given that we need to find it between x equals 0 and 1. So here's like a dotted line of where x equals 1 would be. So we see that e to the x is above x. So we need to find the area of the top function and subtract it by the bottom function. So the top would look like the indefinite integral from 0 through 1, because that's the bounds that they gave us, e to the x dx, and the bottom would be from 0 to 1 of just x dx. So the total area would be the top minus the bottom, so we can just say area, and we can combine these two integrals because they have the same bound. So from 0 to 1, e to the x minus x dx, and if you plug this into your calculator, you should get 1.22. And this is our final answer. Question 2, we have, find the area of the region bounded by the functions y equals x squared, y equals 2x minus x squared. So this time they didn't give us bounds, and we have to figure out ourselves. So we see here y equals x squared and y equals 2x minus x squared just in the first quadrant, and we see that they both meet at 0. So we need to find what this point is, so we have the second bound for the integration. To do that, all we have to do is just set these two functions equal to each other. So x squared is equal to 2x minus x squared. So 2x squared is equal to 2x. Divide by 2, so we have x squared is equal to x. So x equals 1. So this is 1 over here. Now our top function is, we can see here, is y equals 2x minus x squared. So the area for this is 0 to 1, 2x minus x squared dx. Our bottom is our other function, which is x squared. So 0 to 1, x squared dx. And now we have to subtract them. So the area is from 0 to 1, this function, 2x minus x squared, minus this function, so minus x squared dx. And if you plug this into your calculator, you will get 1 over 3. And this is our final answer. Question 3, we have, find the area of the region bounded by the functions in the first quadrant for x equals y squared, x equals y plus 2, and y equals 0. So this is the first quadrant, and this is x equals y squared and x equals y plus 2. And since we're given the functions x equals f of y, we're going to find the area by calculating the rightmost function, subtracting it by the area of the leftmost function. And the reason why we can't do top minus bottom in this case is because we can't really see a clear distinction of, or I guess we can, but that's only for up till this point. Up till this point, x equals y squared is above x equals y plus 2. But after this point, since we're only taking it above y equals 0, this function technically isn't even there. So that's why we would only have one function. So that's why we're going to take the integral with respect to dy. So we're going to take the right minus left throughout the whole thing. So first we need to see what this point is though to see our second bound of integration. So we're going to set both of the functions equal to each other. Y squared equals y plus 2. Y squared minus y minus 2 is equal to 0. Negative 2, negative 1. So we have y equals 2 and negative 1. And we're only going to take 2 here and not negative 1 because they say in the first quadrant, and 2 is in the first quadrant, but negative 1 is not. Negative 1 is the intersection below the x-axis, but we're only going to take it above. So our second bound of integration is 2, and our first is 0. So the top function is from 0 to 2, and or not top actually, this should be right. Right. From 0 to 2 is y plus 2 and dy. And our left is also from 0 to 2, and it's going to be y squared dy. So our total area is going to be from 0 to 2. Right minus left is y plus 2 minus y squared dy, which is equal to, if you plug it into your calculator, 4.22. And this is our final answer. Question 4, we have find the area of the region bounded by the functions x equals 2y squared, x plus y equals 1. So again, we're going to have to find using the right curve minus the left curve. So to do that, we need to find this point here, or just the y values of these 2 points. So we're going to set x equals 2y squared, or just 2y squared equal to 1 minus y. So 2y squared is equal to 1 minus y. So if we bring it to this side, it'll be 2y squared plus y minus 1 equals 0. So now we have our bounds of integration, which is 1 over 2 and negative 1. So this here is 1 over 2, and this is negative 1. So our rightmost function is over here, which is 1 minus x. So we're going to find from negative 1 to, let's just say 0.5 of, and 1 minus x is the same as x equals 1 minus y. And our left function is going to be this curve, which is x equals 2y squared. So let's say 0.5 as well. And now our area is going to be right minus left. So from negative 1 to 0.5, right minus left is 1 minus y minus 2y squared dy. And if you plug this into your calculator, you should get 1.13. And this is our final answer.